In this video we have a look at some examples in the application of the factor theorem. So let's break the factor theorem down. If we've got a polynomial, so that could be a linear expression or a quadratic or a cubic, in other words increasing powers of x which are added together, and there are other examples of polynomials but they're the typical ones. If we substitute into that function and we get an answer of 0, then we can say dividing the function by the linear expression, which is x minus the value that we substituted in, there will be no remainder. So we can say that in this case x minus a will be a factor of the function f at x. Let's have a look at some of that terminology, and we'll use a very simple example to start off with. We know that 12 divided by 4 is exactly 3. There's no remainder. But we can also express the value of 12 as a product, and we can write 12 as 3 multiplied by 4. Now we could have said 12 is equal to 2 multiplied by 6 or 12 multiplied by 1, but the reason why we split it into the factors 3 and 4 is that we are dividing by 4. So when we divide, there's easy cancellation. We know that the solution is exactly 3 and there is no remainder. Given that there is no remainder and 12 can divide by 4 exactly, we can say that 4 is a factor of 12. Let's have a look at that now in an algebraic context. In this example, our polynomial is a linear expression, 2x minus 6. Now we can substitute into that expression and get a value of 0. If we substitute 3 for x, we'll get a result which is 2 multiplied by 3 takes 6, which equals 0. Now the opposite value of 3 is negative 3, and we put that in the bracket next to x, just like in the theorem above in black. So we're going to divide f at x by x minus 3. Now what we'll do is we'll split f at x into two parts. And we can do that by taking the top line of this division and factorising it. And one of the factors is x minus 3. And that allows for easy division. We get an exact answer of 2. So there is no remainder when we divide the function by x minus 3. In this next example, we'll increase the power of the polynomial by 1 and make it a quadratic expression. So we've got f at x equals x squared minus 7x plus 12. We'll now factorise this expression and write it as a product of two linear expressions. That's x minus 3 and x minus 4. So we also know that if we substitute 3 into this expression, we get 3 minus 3 in one bracket and 3 minus 4 in the other. And that's 0 in the first bracket, and 0 multiplied by anything is 0. So if we divide by the expression x minus 3, we should leave no remainder. So f at x divided by x minus 3, if written as a fraction, we can see our two factors x minus 3 and x minus 4 divided by x minus 3. Now x minus 3 is on the top and bottom line, so we can divide through there, leaving with an exact answer of x minus 4, and therefore no remainder.